Hi, everyone. It's Mark Thurman with the MIT Enterprise Forum. I'm the chair of the MIT Connected Things Conference, as many of you know by now. And this year has been an interesting year. We've had, obviously, COVID. Our conference, which was initially set up for mid-March, was postponed to September 14th, which ironically is this coming Monday, as we record it today on the 10th or 11th. But what we've been doing throughout the summer is keeping the conversation going with industry leaders in order to talk about connected things, talk about AI, talk about what's going on in this particular case in the digital transformation world. You will notice on the website that we've posted this, or the websites we've posted these, that there's a number of other resources available. Reach out if you have more questions. In the meanwhile, I want to introduce an old friend of mine, Christoph Inauen from Siemens. We're going to talk a bit about IoT and digital transformation. But first, I want to ask Christoph, after thanking him properly, thank you very much for doing this. I want to ask Christoph to introduce himself and talk a little bit about his company, Siemens. So welcome.
Thank you, Mark. Good morning. And yeah, thanks for having me. Thanks for giving me this opportunity. So yeah, maybe a few words about myself before I then say something about Siemens. So my name is Christoph Inauen. I work for Siemens Digital Industries, where I lead the business called Digital Enterprise and Digital Services in the US region. As a team, we focus on helping customers, on their digital transformation journey. We offer strategy, process, solution consulting services, also implementation and integration services, as well as digital optimization services. We also have a pretty broad portfolio of what we call digital assets, spans from analytics over to artificial intelligence. We also work with blockchain. We focus on production quality improvements and industrial security solutions, just to give you some ideas. So that's a bit about myself, and I'm based out of the Dallas, Texas area.
So, Christoph, Siemens is not a new company, not only not in this space, but in general. I did, my typical Google research and determined that it's a 170-year-old company, started out making electrical goods. So how are you now in the digital services business if you make heavy equipment?
Yeah, so certainly, I need to expand a bit on who we are.
No, that was I find it interesting how companies end up here, and obviously that you have a firm foundation in industrial equipment, but you don't always think about industrial suppliers necessarily being in what we'll discuss in a minute in the digital transformation space. So tell me a little bit more about the journey there.
Yeah, absolutely. So, your research is pretty accurate. I think we're, to be precise, 172 years old.
Okay.
We see ourselves as a global powerhouse. We're leading in electrification, automation, and digitalization. From a business point of view, we have different businesses. One is called Siemens Smart Infrastructure. So those colleagues, they focus on building technology items. Then Siemens Digital Industries, where I belong. So we're focused on manufacturing. We have Siemens Energy, Siemens Healthineers, so they focus on the healthcare industry, and Siemens Mobility, so they focus on trains, rolling stock, solutions and systems for transportation, for the transportation industry. But I think a lesser known fact, which I think is really interesting, is that Siemens is also one of the 10 largest software companies in the world. So, we've been in this game for a long, long time, and there's a lot of people don't understand that about us. But yeah, we're one of the 10 largest software companies. We employ about 350,000 people around the globe. Also, an interesting fact is, since we're here in the United States, we have over 50,000 employees in this country.
Wow.
So, I think it's also pretty impressive, and a fact that a lot of people don't really know about us. And from a revenue point of view, so last fiscal year, so that's 2019, we created over $100 billion in revenues. I think that's pretty impressive. Wow. Now, as a company, we have a very strong focus on what we call global mega trends. That is globalization, the fact that everything becomes more global, urbanization, more people moving to the cities, all of that, demographic change, so population growth. And we focus on climate change and digitalization, which is a huge topic in itself. So it's one of the mega trends that we identified, and that's what we focus on. So hopefully that gives you a little bit of background about who we are as Siemens.
No, it's remarkable. I mean, I see the brand if we go to a medical office, obviously different group than you, but you see them with these big X-ray and MRI machines. So it's not a hidden brand entirely, but it's not you're not a maker of consumer goods. So again, in the U.S., you probably would only encounter them in a doctor's office, or if you were looking at transformers or building a factory, perhaps.
Right. Yeah, that's true. So when, if you keep your eyes open, when you go to a hospital, for example, you'll see Siemens in many places.
That's right. That's
For
exactly
sure.
right. So as we were saying, you're again, which I didn't know, one of the 10 largest software companies. So that's kind of a remarkable fact. Uh, a lot of what I think you've been working on in the IoT space is really, this great new term, or not so new term, called digital transformation. When I talk to some of my friends in the market research world and the analysts, they don't like the word digital transformation. They can't quantify it. It's misused broadly. In fact, one of my friends, Frank Gillette, likes the word adaptive enterprise. So before I kind of go on from there, what do you think is digital transformation? Is it one of the mega trends that you've just noted a few minutes ago? And how do you guys look at that market?
So yeah, I mean, digital transformation, it's one of those buzzwords out there, and people understand it in various ways, right? I mean, the way I look at it is I also actually talk about the digital enterprise and not just digital transformation. So what is the difference? In my mind, digital enterprise basically is a company that applies digital technology and uses it at the center of how that organization, in my mind, for example, produces products or services or generates revenue or actually operates, right? So that's an important aspect. Then digital transformation for me is actually, you apply digital technologies, but the important piece is in combination with services to create new or to modify existing business processes, right, or customer experiences. So it's all about the business impact, right? And ultimately the business value, that's what matters to me the most. And that's the way I look at digital transformation. So it's just how you apply, so you select technology and then how you apply it. But the goal is to improve business processes, become more operational efficient, et cetera, et cetera.
So how does this manifest itself? I don't know, pick a use case that's, kind of, you can strip it down just for the purpose of conversation. So as I recall from our many prior conversations, there may be very old machines in a factory, 20, 30 plus years old. How do you bring those 20-year-old bits of gear into the 2020s?
Yeah, absolutely. So it's true. If you go into manufacturing, right, you will find systems that are quite old. And so one challenge is to basically build a data connector to these systems. But that's something that we Siemens we do. So we have special teams that focus on that. So you can collect the data or get access to the data. The important piece, though, is the way we look at the world is we try not to interfere or interrupt these systems, right? Because they execute, especially in the manufacturing world, very important tasks. So you don't want to mess with those systems. So the trick is to get access to the data without interrupting the systems. And then once you have the data, the second step is you have to actually give that data a certain meaning or context. And so I think that brings me maybe to the next point, right? If you want to run especially analytics, the definition of the data, the understanding of the data is super important, especially then if you want to run analytics across multiple systems, becomes even more important. And then, we go into this direction of building out the semantic layer, etc. So it's connectivity to the systems, it's the data collection, it's the building the understanding about the data. That's really important, because at the end of the day, what you want to build is you want to create insight from the data, right? And insight is then taken to drive actions in the business. So data in itself is pretty meaningless, but it's a necessary evil, right? You got to get access to it and understand it.
So you mentioned the semantic layer. Let's kind of delve into that a little bit. What does it mean? How do these, again, I'm thinking of an old compressor in a factory. How do these older things in the factory communicate today? Where there's I like this analogy. Do the bits just fall on the floor? Do they go somewhere? Have they, for 30 years they haven't used it? Now all of a sudden it's of value. So I'm just curious, how it all sort of comes together.
Yeah, absolutely. A good question, Mark. So, the way I see it is that, these systems, they generate data. Data has been generated for a very long time. Data is also stored, in almost all the cases that I know of. But the question is always, is the data also used, right? And this is where things get tricky. A lot of the companies, they don't really use or leverage the data. Maybe at best they create a dashboard, they look at it every now and then, but it's not, interactive, it's not in real time. And, it's more like you collect data for the purpose of creating a kind of a backlog, a history, right? But it's not to use it proactively in a real time environment. So that's what I see as the challenge. But then there is also machines that, their ability to kind of create data is somewhat limited. So in those cases, we would actually install new sensors, for example. And, some analysts predicted there's going to be like 50 billion of those devices or sensors out there actually by now, right? I don't know if that number is exactly right, but it's definitely a very large amount. So you basically complement legacy systems with new sensors. So with that, you can create new data patterns and data sets. And then you create that combination. And with that, it allows you to build a comprehensive understanding about what's really going on at an asset level, for example. So you talked about a compressor machine, something like that, right?
So is this what you call the semantic layer, just to be really specific?
Not necessarily that in itself. So I would say the semantic layer should build an abstraction to the various data pools. So data is stored in, system A, B, C, and then maybe there's data that's stored somewhere in a database that comes off a generator or, what have you.
Right.
And then if you want to run comprehensive analytics, maybe at a system level or an overarching system level, you got to build a common data understanding layer, so to speak. And that, in my mind, is the semantic layer that gives the data that comes from these different pools a meaning, so you can run analytics, in a meaningful way. So you can build an algorithm, for example, and it's easy to understand the data, the context of the data. So, and you got to build that. You got to make that investment, in my mind, if you want to do it properly.
So would you incorporate things like predictive and prescriptive maintenance in this bucket, in this digital transformation bucket? Because I know that was some of the earlier, that stuff you and I worked on in our past lives here and there. But that was one of the earlier use cases of connecting, industrial machines to networks in order to monitor them. So monitoring and controlling was certainly one aspect. But then it was, I've got a whole bunch of turbines. I've got a whole bunch of things that are spinning. What if I can predict failure? So companies have been coming up with, predictive, prescriptive, application sets. Does this fit within digital transformation, and is the semantic layer related to that?
So in my mind, yes. It fits right there. It's something that a lot of our customers focus on these days, right? It's to build a better understanding about how the assets they use perform. They want to understand, better at what point something might actually fail, so they can, optimize how they maintain these assets, schedule services, etc. Maybe even the way they order spare parts, right? Things along those lines. So this is absolutely happening, and it's part of what I call digital transformation. It's one aspect of it. And yeah, I mean, the semantic layer will come in my mind, if, in order to create that prediction, you have to look at data that resides within different systems and different data pools. So to basically abstract it, to normalize it somewhat, so you can create these algorithms that actually at the end, make those predictions, right?
I think this makes sense. Now, I'm aware, I know the answer to the question as I ask it, but I'm aware that Siemens is also in the IoT platform space. But could you talk a little bit about that? I know it's called Mindsphere. And then how does that all sort of work with what we've been talking about? And then, the follow-on will be, can you bolt on additional tools from third parties, or can the enterprise build their own tools? So let's talk about the platform a bit.
Yeah, absolutely. So I'm happy to say a few words about what we call Siemens Mindsphere. Now, it is true, on one hand, it is a IoT platform. So it offers the enablement layer for IoT, so to speak. But at the same time, Mindsphere is much more than just the platform, right? And I'll speak about that in a minute. But if we focus for now on the platform, so the platform allows you basically to connect to assets, to sensors, to collect the data, bring it in, and store it, but also let's say prepare the data so that it can be used, for example, by the application development environment in the right way. And you can also use it then to create predictive maintenance type scenarios, etc. So the platform, yes, it's important, and I call it the enablement layer. But at the same time, what customers really want, they want an end-to-end solution, right, for the lack of maybe better term. So the customer have an expectation that, yes, a company like Siemens, we have an IoT platform, but we can also, let's say, develop applications. We bring it all together. We can interact with other systems. We can trigger when we create inside business processes, for example. So, right, it's the whole system environment that really matters to the customer. So for us, Mindsphere is such a complete solution landscape, and it's made up of different, let's say, building blocks. We also have Mendix, the low-code, actually the leading low-code application development platform tied to it. So it's real fast and simple to create new applications. So it helps actually with the ROI, right, the return on investment. So if you can build an app with within a very short period of time, it helps tremendously to have a positive business case, for example. So that combination as well is super important. So we don't just look at it as a platform; it's really a system level solution.
So we talked about kind of making sure that legacy systems, old machines, are able to interface into this kind of brave new world. How do we help the people interface? So you've got, compressor whisperers, or guys that are really good at, if they listen to the vibration, they can tell when an oil well is going to fail because they've been around it. Are these tools useful in that setting with a 50-plus-year-old factory worker, or
Yeah,
how do we help them?
absolutely. So I mean, there's two aspects to that story in my mind. I mean, one is certainly the user interface that we create, that has to be easy to understand and so forth, and it has to be intuitive, right? So this is where again Mendix comes in combination with Mindsphere from a solution point of view. But you bring up another good point that I think is worth talking about, because we can have tons of data scientists, and we can throw them at a problem, and they're very smart people, and they will detect patterns, right, in the data sets. But what is super important is the point that you brought up, the person that has that expertise and experience, that can listen to maybe a motor or something, and just from experience tell that there must be something wrong here, right? To bring that, I call it domain expertise, into the mix is super important. So ideally, the guys that have that expertise and all these experiences, they would work together with data scientists. In that combination, they will be able to create the most accurate prediction algorithms, and ultimately, that's what drives the business forward, right? So it's a real good point, Mark, and this is also the point that we bring in as Siemens with our domain expertise. So it's not just that we have technology, but you have to understand how these machines operate, at any given moment in time, right?
Well, I always say that, when you read these articles that talk about the demise of the worker and everybody's being replaced by robotics, I always remember that machines have to be operated by people. And, again, there's always that guy with the greasy cloth in his back pocket that's walking around the factory that is the only one that can make stuff work. So it's not the data scientists that are keeping the factory running. It's the experienced worker that's been there that, again, can hear changes in a turbine before the software can predict it, perhaps.
No, I agree. I mean, I think, again, that combination of the data scientists and the guy who actually operates these machines and has all the experience, that combination is powerful. The one or the other standalone, maybe not so much, right? So in this new digital world, right?
So no, it makes total sense. So speaking of the new digital world, there's a lot of stuff in the press when we talk about IoT and digital transformation around 5G and 5G private networks, 5G networks. Your company, among a lot of the other European players in particular, are getting their own 5G spectrum. I know you're not a 5G telco expert, but if you could talk a little bit about what's the impact of creating these networks, what are the benefits, and what are you guys becoming a telco?
No. Short answer. No. So, but yeah, seriousness. Let's talk a bit about 5G. In our mind, it's actually industrial 5G, right? So again, we don't focus on the public 5G networks. That's not our space, right? But it's industrial 5G. So the networks that are going to be deployed, for example, in factories. And this is where we're making a lot of investments. That's where we're building out a portfolio of products and assets. So it's all about, for us, it's all about industrial 5G. And in terms of use cases, so by the way, also maybe to do a little advertisement here, so we have a dedicated 5G Siemens website. If you just Google Siemens 5G, it's easy to find it. And so on that webpage, we talk about some of the use cases that we see to arise, especially in the factory environment. So it's like things like assisted workers. So if you have a guy on the shop floor, let's say you can stream live data to that person about the tasks that they're about to execute, things like that. 5G may also help with autonomous machines or in the area of autonomous logistics. And then certainly also in the field what we call industrial edge, again, the data rates and the volume of data, the latency issues and all that. It can be used for industrial edge components as well. So those are just some of the use case areas that we see to develop at this point in time. There will be many more down the road, but we got to start somewhere.
So to kind of simplify it and noodle on this a little bit. So these are cellular standards. They're not somebody in the on a public network, on a telco network in Europe can't see or look at or discover any of these machines. So they're using a cellular 5G standard, and what you're able to do is envelop an entire factory complex or campus with things adhering to the 5G standard, which have high data rates. They're fast, low latency. There's no delay, and all of that. Would you say the benefits also include things like I don't have to wire them in, so the machines can move around, or I can reconfigure the factory? Or what are some of the other aspects that make this appealing?
No, I think you're absolutely spot on with that remark, Mark. I think these are exactly the type of use case scenarios that we see. It gives our customers more flexibility in terms of how they maybe rearrange their production lines and things along like that, so they don't have to wire or rewire all the things all the time, and just it gives them more flexibility. And also the way workers can be equipped with, let's say, tablets and other tools, or what's the word I'm looking for? The augmented reality
Yes,
scenario with,
goggles,
yeah, with goggles, right?
AR,
Stuff like
VR,
that.
right?
Exactly. So those scenarios can now be really and truly enabled, right? And you don't need a wire, obviously. You're right. You can move around in a factory, and so there's a lot of benefits right there in the technology, as you said. With low latency, high bandwidth, all that good stuff. That is the enablement layer for those use case scenarios, and that gives our customers a lot more flexibility.
Yeah, so it's I think there's obviously 5G, and I won't go into any of the popular myths that we've been seeing over the summertime, certainly, but 5G is really just a communications standard that envelops or excuse me, that encompasses cellular, Wi-Fi as well, some of the older standards or the slower standards, including NB-IoT, narrowband IoT. How do you see that playing out, some of the lower data rate standards? Again, I know you're not a telco guy, but I think Siemens is deploying assets that are not always speedy, because sometimes you don't need fast. Sometimes you just need, is it on or is it off?
Yeah, absolutely. No, I think, I mean, especially short term, my prediction is that 5G will not replace everything that's already out there, right? So I think it will start with very specific use cases around applications that are, as I said, bandwidth demanding, they demand low latency, all that stuff. But for, let's say applications that are let's say less demanding in that sense, they can still run on, call it, the more legacy type systems, and maybe there's going to be a transition over a period of time, from these legacy systems and over to 5G. I mean, we also need to see that and understand that 5G networks, it's not just the network that matters. You also have to have the devices right on the other
That's
side
right.
of the equation that need to be equipped with it. So initially, it's maybe also going to be a question of cost, because I mean 5G modules will be a little more expensive than maybe what's been out there for a longer period of time. So this is also something that needs to be considered. So it's also the cost aspect. I mean, even when you go into a factory, right, you have different networks today. There's Wi-Fi networks installed. There's more
Right.
proprietary networks installed, narrowband, etc., and they may coexist for a certain period of time.
Yeah, I think it makes sense. I think it makes a lot of sense. I know there was a lot of confusion when the new G comes out, and people predict things. But as I said, what's different, in my opinion, this time on 5G versus 4G was the creation and deployment of these special networks. You didn't see, I mean, private LTE did exist, and again, I don't want to go down the telco path too much further, but you didn't see it as much as again, with the influence of a lot of the European manufacturers, where they've embraced this Industry 4.0 notion, and 5G kind of coexisted and came, it just the harnessing all these modalities at the same time, I think was a perfect storm for again, Siemens and their peers. So I think we're on the home stretch here. So I wanted to step back a little bit from Siemens. You've been in the IoT space for a long time, and you and I have worked together in different settings for a while. So where do you see, kind of the industrial IoT space going? And again, if there's 5G as an overlay in terms of propelling growth or things like that, I'm just curious, where do you see this going, since you have an interesting background and an interesting ability to see what's going on globally?
Yeah, absolutely. So I mean, certainly on 5G, right? I see that as a very important technology that will allow to create many more use case scenarios slash applications, especially in the industrial space. So I think this is a super critical and important technology that any company out there in the manufacturing world and otherwise should really consider. Then what I'm seeing in terms of, let's say, digital transformation trends. So from a technology point of view, what I'm seeing is that, besides the IoT platforms that have been now around for a bit of time, they're there to collect data, to process the data, to be the interface to the application development environment, et cetera, et cetera. That's an important, let's say, a topic that will continue. But what I'm also seeing more and more is that, artificial intelligence as a field of analytics is gaining tremendously in importance. Right? I think you're going to see artificial intelligence also in the industrial space deployed, in almost anywhere in the next, 10 years or so. Already today, there's so many applications in the field of artificial intelligence in the industrial space, and that's just going to grow. It will help to automate processes, to detect failures, et cetera, to become more efficient, right? To eliminate maybe human errors or potential human errors, things like that. What we're also seeing is a big trend in the area of simulation. So you want to basically more and more simulate things before, let's say, you build something, for example.
So this is digital twin.
It goes in line with the digital twin concept, absolutely. And there's different flavors of digital twins.
Yes.
In the Siemens terminology, we have 3 digital twins. So one is digital twin of the product, digital twin of the production environment, and then digital twin of performance. So that's the digital twin of the actual assets that you operate in the field.
So if my math is right, that's digital septuplets. Sorry, little nerd humor for our listening audience.
But yeah, for me, it's a super important topic, And then also what we're seeing in terms of trends is, that blockchain as a, call it technology, is gaining in importance. It helps in the area of, let's say, supply chain, for example, or the way you exchange information with other parties, so in an immutable way. So super important, or how you deal with transactions, et cetera, et cetera. And then the other trend that I'm seeing is, the trend between, let's say, cloud and the edge and on-prem, whereas the edge is gaining a lot more importance. A couple of years ago, everyone was talking about the migration from on-prem to the cloud. Now the cloud is somewhat established. Now the next big topic is edge, which adds another layer of complexity, you can argue, but at the same time, it also allows for a lot more flexibility and truly to execute tasks, where the action takes place. So you don't always have to go back into the cloud, process all the data there, et cetera, et cetera. So these are some of the trends that, I'm seeing out there. And I think we're all going to be super busy, to work in these trends in the next couple of years.
Yeah, I hope you're right. I hear the term hybrid cloud a lot. I think our friends at IBM use that term quite a bit in their strategy.
Yeah, I mean, that's true. It's a term that I've come across a few times as well. And, it's certainly also something that we talk about at Siemens. I think, for me, though, it's one of these things, it's another buzzword, you can claim. But the importance is that you can explain the architectural implications to the customers. And I mean, that's what the focus has to be. How we call something, it's detailed.
But Gartner for years had their hype cycle. I'm not sure if I haven't looked at this year's hype cycle lately. I think I saw it once, but IoT was on it, and blockchain has been on it for a long time. I think digital transformation, all the terms we've been talking about. So it sounds like what you're saying is it's less hype cycle and it's more we're just rolling this stuff out.
Yeah, I mean, for me, the most important aspect is, we can talk about technology all day long, and I love technology, but technology in itself, it doesn't matter, right? The important part is you gotta tie the technology to the business value, right? In other words, you have to define first, what do you want to achieve? What is kind of your pressing issue as a business? And then you apply technology to solve problems. So the business value that you want to, let's say, gain by applying technology needs to be spelled out at the very beginning. And again, then, if you call something hybrid cloud or whatever, for me, it's semantics, right?
Right.
It's not that important. So it's really the business value that needs to be in the forefront of every discussion. And I think that's also maybe last point, Mark, from my side. That's also the reason why I do think that so many POCs, the proof of concepts, are no success, because they focus on, testing technology. But again, they fail to actually link it together to the actual business value.
Business outcomes. Yeah, that's right. And that's how every vendor and again, I don't want to turn this into a second broadcast, but every vendor just talks about business outcomes, and then they get on things like this and complain, oh, I'm stuck in POC hell. Well, it's because you're just, I think you rightly pointed out, this is a little nugget that you just kind of point out, is that, they're too busy testing technology, not testing business outcomes.
Exactly right.
That's interesting. Maybe that's a good place to leave it for now. Christoph, I want to thank you very much for spending some time with me on this and talking about outcomes in technology. I like the technology. I like the outcomes. And as everybody knows, this has been a program in support of MIT Connected Things. We hope to resume live conferences depending on how things go globally with the pandemic. Hopefully early next year, early 2021. So we've been doing a series of conversations with industry leaders like the one that you've been watching with Christoph Inauen from Siemens. So I thank certainly the audience for participating and supporting us. And most importantly, I want to thank Christoph for his time and his insights. And I don't know if you have any parting shots, but thank you very much.
Thank you, Mark, for having me. It's been a real pleasure, and look forward to hopefully get another chance to do something like this in the future. So thank you, Mark.
Absolutely. Thanks.